Beneath the surface, where steel meets fire, a hidden gas is being created. Hydrogen, invisible, highly flammable, and produced every time a diver cuts underwater. It forms in two different ways, through electrolysis and through an intense chemical reaction driven by heat. The moment the current flows, the rod turns hot. Electricity passes into the water, and almost instantly, clouds of microscopic hydrogen bubbles begin to appear at the tip and at the rear of the electrode. The higher the current, the greater the flow. At around 150 amps, typical for most cutting rods, more than 100 cubic centimeters of hydrogen can be produced every minute when the current is on and no cutting is done. But once the arc is struck, everything changes. The current concentrates in the arc itself, and hydrogen production at the tip drops sharply. But at the rear of the rod, it continues. In confined spaces, that matters, because hydrogen rises and it can accumulate. The solution is simple. Switch to cold. No current, no electrolysis, no hydrogen from this source. In fresh water, the effect is far less pronounced. With lower conductivity, electrolysis is reduced, and hydrogen production drops to minimal levels. But there is another source, more subtle, more intense, and this is when molten slag at temperatures above 2,200 degrees Celsius meets water. Then a violent microreaction takes place. A thin vapor layer forms instantly around the glowing metal. Inside it, trapped water molecules are torn apart, separating into hydrogen and oxygen in just milliseconds. Oxygen reacts with the metal. Hydrogen expands the bubble until it bursts free. Then the process repeats again and again until the slag cools. This reaction alone can generate hundreds of cubic centimeters of hydrogen during a single cut. As a result, a single exothermic rod can produce around 400 cubic centimeters of hydrogen gas because of the electrolysis and the heat. Enough to matter, enough to become dangerous if trapped and mixed with oxygen. Can it explode? Yes and no. It all depends on the environment. To understand when and why, refer to the full study. Because underwater, what you don't see can hurt you.